I want to come to you, Dr. Desai, first, because you've been deeply involved with this project. The Pragyan rover is out there. We are told it will move at a speed of 1 centimeter per second for the next 14 days. Can you give our viewers a sense what exactly will the rover do during this period?
Yeah, so as most of you are now familiar with that yesterday, after the soft landing of our lander, we initiated the initial operations related to putting rover onto the moon surface. And we first brought down the ramp, which was part of the lander. So it touched the moon surface, and on that ramp, the rover rolled down that ramp. And of course, we faced some of the initial teething troubles related to the initial rover operations of rolling it down the ramp and putting it on the moon surface. But we could overcome that challenges also. And by yesterday, 12 o'clock, our rover was moving onto the, just rolled down to the ramp and moved onto the moon surface. And initial pictures were taken of that particular rover movement from our lander imager, which is part of the lander. And as you said, the rolling speed actually is not 1 centimeter per second, but it is 1 centimeter per minute. That is what we'll be using for its now continuous experimentation, which we want to do for next 14. In fact, actually it is 12 and a half days, because we landed on the second day after the sunrise on the moon. And generally one moon day is equal to 14 earth days. So considering that we have now 12 and a half days of experimentation left before the night sets in on moon, which is the some frightening part, because at night temperature on moon goes up to as low as -120 to -150 degrees centigrade. And that will incapacitate some of the electronic circuitry. So what we'll do is that we'll switch off the rover after these 12 and a half days of experimentation, and after 14 days of night, we'll again try to revive.
Fascinating listening to that. 1 centimeter a minute is what the rover moves at. Dr. Amitabh Ghosh, NASA Mars rover scientist, what are you looking forward to over the next 14 days? What's going to be exciting you? Apart from those pictures, which are just brilliant.
Right. So I just want to correct, it says ex-NASA scientist. I have mentioned it a couple of times to your team. So, yes. So as you said, well, it's going to be very exciting, the 14 days. So we're just beginning. So I think marginally the chairman has mentioned route planning. So the rover now has to figure out where will it go. So probably the scientists are right now scanning interesting targets where they want to drive to. And then there will be probably rover drivers who will assess how to get there, and they will get there, and then the scientists will make some analysis, and then that will be downlinked back to Earth, and then the scientists will again look at it and see, well, what did they find, and then they might make more analysis at that location or drive to a different location. So this process will continue until 14 days. But
anything specifically that you're looking at that you are excited about?
Yes. See, obviously everybody is trying to look at hints of water. So the analysis of the regolith. Regolith is the top layer of the soil. See, on Mars, you get water below the regolith as well. So the Chinese rover and our latest Mars Perseverance is looking for that. So that is interesting. And then, of course, I don't know how far they're from the ice deposits, from a crater. And, the time is a little short, so I don't know whether there's time to go to the crater. And the other thing that you have to understand, I don't know what the range is. So, the rover communicates with the lander, so it kind of has to be in contact with the lander. So how far can it go without being out of range? But the ice deposits are very, very critical. And that is what the entire community wants to know, as to whether it is ice one. See, that is what we verified with Mars Phoenix. Just because you have to make sure by measuring the composition, it is really
right.
H2O. And then what is the temperature of the ice? that's, if you're trying to extract ice, melt that ice, there is a heat equation involved there. So is it feasible to melt the ice? So these are the type of questions that probably
these are of course questions for the future. Dr. Suresh Naik, former Group Director ISRO, what are you looking forward to in the next 14 days?
Yeah, actually, first I would like to explain what is the moon crust formed of. You see, the moon crust, which is a loose soil, is formed of three different things coming from three different sources. One is there is a lot of bombardment of the celestial objects like comets and meteorites, etc., continuously happening on the moon, and since there is no atmosphere, they happen at a very large speed. And that is one thing which has been crushing the rocks there since last millions of years, and this small powder of the rocks is there on the moon soil. Second thing, volcanic activity, when it takes place, the volcanic ash gets thrown out and deposits in the moon soil. And third thing, when the big objects, celestial objects, they impact on the moon, then big craters are formed and the inside material is thrown about outside, and that also is mixed with the moon soil. So what we are trying to do by means of a rover is try to analyze the soil. The advantage which we have got is remote sensing. We don't have to dig up. We don't have to have an arm to dig up like Russian Lunar had provided. We had to do it only from remote sensing, and there are two ways of doing it. One is the alpha particle X-ray spectrometer. Second is laser based spectrometer. Okay, alpha particle X-ray, it throws the light, throws the thing on this soil, and when the X-ray gets reflected, rover picks it up, and that tells what the composition. Second thing is when the laser based array is going there, then that burns up the materials on the surface, and the plasma is created, and plasma also creates light, and that falls back on the rover, and that is really interpreted into by means of the wavelength into what materials they have. So by means of this, we will know the composition. Second one is the laser based one, I already told you, and the difference between laser based and the alpha particle X-ray based instruments are laser based instrument can go deep inside the soil of the moon, whereas the alpha particle X-ray will be doing the surface soil analysis. So this is the basic difference. And what the exciting things people are expecting the rover to find out is whether we come out with a discovery of precious materials, minerals like gold, whether there will be helium-3, whether of course there will be aluminium, oxygen and silicon. We know that they are there. Okay,
so you're saying finding the minerals,
and of course the rover is also going to find out the water content.
Right, so it's the water content, but finding out what are those
in the soil.
Yes, Dr. Ghosh, you wanted to come in.
Pardon?
Right. So I measured the first Martian rock with the alpha proton X-ray spectrometer, and we have it in the four of the NASA rovers. See, it's a good instrument, but it has a relatively large margin of error. So you will be able to tell, but not in that detail, and it tells chemistry, and then it doesn't tell mineralogy. So you can say these are the elements present, but not what is the structure of that element. It does not have a sensitivity throughout the spectrum.
Right.
For that, you need something more sensitive, with like a mass spectrometer that we have it on Curiosity. So it will give you a generic idea, and I don't think it has sensitivity for water that the laser instrument has to tackle. So it's a good instrument, but it's a first cut thing. The imagery that will yield some more information, but abroad, for example, in our Mars Pathfinder mission, one of the very big discoveries was, we assumed that the Mars was made up of basalt, the rock type of basalt. But we found from the first few analysis that it's a rock type called andesite, basalt, a volcanic rock type. This is all based on the alpha proton X-ray spectrometer silicon content. But the silicon content also has a margin of error, plus minus 2% maybe.